Okay.
So, hello everyone.
Yeah, just one. Wait for a second.
Yeah,
Uh, so, participants, I'm introducing the today's guest for the session, 12 number session, Mr. Rishikesh Gaikwad, Director, LAM Research, Data Sciences. He will be the session presenter for next 1.5 hours. Let me introduce his brief biodata. Uh, he has completed BE Production Engineering from KIT College of Engineering, Kolhapur. He is a gold medalist for the UG degree program at Shivaji University. He has completed MBA program, postgraduate program, executive management program from SP Jain Institute of Management Studies. Uh, as well as he has completed Master of Science Business Analytics from Georgia Institute of Technology. Currently, he is pursuing PhD from Savitribai Phule Pune University in the supply chain management. He has been worked with various organizations. He started his career with Cummins India Limited, moved on to say TCS for longer duration. He was a project manager and raised to the level of say consultant in supply chain. Further, he worked for business partner with Syngenta. Then he worked with say with ETOR, and currently he's working as a director data sciences at LAM Research India, Bangalore. His vast experience in the field of say supply chain will benefit our participant. So I request, without wasting time, I request Mr. Rishikesh Gaikwad to continue the session.
thank you very much, sir. Um, let me share my screen and share the presentation. Let me know once you start seeing the presentation.
Yes, the presentation is visible, sir. Please make it as a PPT mode, sir. It will be good.
Yes. Is it still visible?
Yes, sir. Visible only, sir.
Okay.
Okay, sir. Thank you.
All right. So, thank you very much, Zeal Institute, for giving me this opportunity to present to the esteemed audience across India from the academia and industry. As Mr. Shalar explained, I have mostly worked in industry only, not worked in academics as such. So all my experience will be talking about how application of uh, data is there in industry. Today's topic is data-driven decision making in supply chain management. Uh, most of my experience is in supply chain management field, and today we are going to talk about how data is getting used in supply chain management and how there is a progression over years. Um, Currently, I lead a data science team in LAM Research, Bangalore. LAM Research is a semiconductor equipment manufacturing company. We are producing advanced machines which can produce 2 nanometer uh, semiconductor chips also nowadays. And we are largely contributing to AI and the machine learning era that is all of us are going through. Uh, Most of the companies like Samsung, Apple, Intel, TSMC are our customers. Uh, all the chips, those are almost 95% of the chips in the world are manufactured by using LAM machinery. Uh, and it is really advanced technology utilizing plasma etching and plasma deposition, plasma cleaning methodologies. And My team mainly focuses on data science and advanced analytics related solutions to the operations management of this company. So supply chain and operations is generally interchangeable term. We study operation research, we study supply chain management, and we learn optimization techniques in our engineering, like linear optimization. Some in the last session we are talking about gradient descent algorithms for optimization. So I would say machine learning And in some sense, artificial intelligence is extension of statistics, extension of those optimization techniques, leveraging the machine power so that large data sets can be churned faster to come up with a quick decision. Uh, as the topic is data driven decision making and supply chain management, my focus will be on those points. But the field of study or field of work that I have goes beyond this many times. But today we'll focus on supply chain and data driven decision making. You can ask questions anytime during the session. So let's first define what is supply chain management, because sometimes there is an ambiguity. Supply chain management in industry generally has logistics to move goods from one place to another place, sourcing, finding, and evaluating suppliers so that right material can be procured. Obviously, once we source and established suppliers, we need to continue procuring from them. So there's a procurement department under supply chain, like issuing and tracking purchase orders. Once we place orders, those orders will be received in warehouse physical. So warehousing is also part of supply chain, where we talk about storing and handling inventory. Anything incoming to a factory needs to be checked for quality. So quality management, monitoring and ensuring product standards. And then obviously order management, processing and fulfilling customer orders. All this is part of supply chain. Some organizations name it differently, but at a high level, logistics, sourcing, procurement, warehousing, quality management, order management, these are the functions typically which fall under supply chain management. Now, if you look at logistics, right, the main sub functions under logistics are inbound logistics, where we are talking about managing transportation and storage of raw material from suppliers to manufacturing facilities, like incoming material. Then outbound logistics consists of distribution of finished goods from production sites to customers or retailers. And then the transportation management for moving goods, like route optimization, carrier selection, freight cost control. These are all part of transportation management sub-function. And reverse logistics, like handling returns, recycling, disposition of products, the pallets which need to, or crates which need to be brought back. All that is part of reverse logistics. Even cars from, say, Maruti Suzuki plant in Gurgaon move to Chennai, and from there, Hyundai cars move up to the north of the country. That's reverse logistics, right? So how do we optimize both sides of the transportation lanes and make sure that the material which has gone, whatever needs to be brought back, it should be brought back using reverse logistics. Going to sourcing, we talk about supplier identification and evaluation, finding reliable suppliers based on cost, quality, and capacity. This is a very important function. Under sourcing, generally, we talk about there should be a resilient supply chain. That means if one supply stops, there should be an alternate supply available. At the same time, we should not have too many suppliers for the same component. Otherwise, there becomes a logistical problem as well as management problem. And we should not depend on a single supplier as well. So a lot of decisions need to be made by sourcing. There's a negotiation based on quality, negotiation based on cost, negotiation based on the overall financial stability of a supplier. And there are a lot many factors which get involved in identifying and evaluating a supplier. Then negotiating a contract with a supplier in terms of price, delivery, compliance. There's a large pressure on working capital management. So how do we reduce the number of days of supply? That is a constant KPI on which sourcing is getting measured. And obviously risk management, diversifying suppliers to mitigate geopolitical and supply risk. Like in nowadays, with these geopolitical tensions all over the world, you never know when a supply line will be disrupted, and there can be climatic events as well, which will also reduce and affect the supply chain. So the risk management, there are specific softwares nowadays which will constantly monitor a particular geographical region, a particular type of commodity, particular types of suppliers, nations, and there is a feed in terms of risk, and that can be utilized by sourcing team to proactively take actions to mitigate the risks arising out of the geopolitical or any other events. Going to procurement as its name says, suggests it's a purchase order management, issuing and tracking of purchase orders for raw materials and components. As the customer orders change or get confirmed or configurations are finalized, then there is a ripple effect from order management to procurement. As the MRP is run, many orders get cancelled, pushed out, pulled in, and a day-to-day life of a buyer is to make sure that all those purchase order suggestions are acted upon without disrupting manufacturing, without adding more inventory, and without creating more shortages. So more is bad, less is bad. It should be just in time. And then there are a lot of variables which affect the demand and supply. There are variables on the order management side. There are variables on the supply side as well, and there are variables like quality. There are variables like manufacturing related downtime or any issues there. But still, procurement has to make sure that right amount of material is available, not excess, not less. It's a very painful function in a supply chain. Procurement is a very tough job. Spend analysis is something to monitor and optimize procurement costs, especially in indirect material procurement. This comes under the radar always, and there is always an ambiguity. Looking at the invoices or looking at the purchase order lines, it is really difficult to classify what kind of spend it is. Generally, this problem is evident in larger organizations where uh, thousands of purchase orders are getting created every day, and unless there is a visibility on what kind of category we are spending, there can be frequent like budget overruns happening. And this, generally the indirect cost is a cost, right? It is not a revenue linked cost, and hence there's a lot of emphasis on reducing the indirect material cost. So for that, spend analytics is a major function in indirect. In direct procurement, spend analytics is a function, but that is generally related to how do we optimize the inventory by optimizing the parameters like lead time and safety stocks and reorder quantity without affecting the flow of goods and flow of material outbound from the factory. The most important part for procurement is compliance and governance. As we are talking about relationships involving money with suppliers, there's a lot of possibility of missing the compliance or people trying to leverage the position in their organization to benefit themselves, and hence there's a lot of emphasis in the organizations for compliance and governance. So it's a big function in multinational companies, constantly on a vigil to check whether procurement is happening as per ethical standards or not. And the tariffs and governance and compliance is another part where there are regulations in terms of what we can buy from which country, what we cannot sell to which country. The duties get updated every now and then nowadays. So we have to comply with those tariffs and duties to make sure that the company is compliant with all the government regulations. It's a big function and a very important function in supply chain procurement. Going next, quality management, we talk about incoming quality control, like inspecting raw materials and components upon arrival, monitoring production processes and maintaining standards. Then supplier quality audits needs to be done. Like we go to the supplier and evaluate supplier facilities and practices. Especially there are laws related to child labor also. So we have to ensure that the supplier is not employing any child labor. Some supplier is employing safety practices. Supplier is ensuring quality procedures and practices. Supplier ensures that the process control is in place so that the defects don't flow into the original equipment manufacturer. And continuous improvement is also part of quality management. So for each and every defect or a problem, there is a kappa action, right? Corrective action and preventive action. And then there are 8D methodologies, and there are many quality procedures which go through the drill through the problem and find out what are the root causes and make sure that those don't happen again. So there are a lot of emphasis on how do we control quality problems from reoccurring. And Six Sigma and Lean methodologies, most of you are already aware, but that is getting really practiced in the organizations. Organizations run certifications, Six Sigma certifications and Lean certifications as a strategic initiative. And then as part of the certification, there is a requirement to have projects executed. It's not just attend a session and get a certificate. The participants have to do some projects as well. And then there is a for Six Sigma, there's a master black belt who evaluates the impact of the project, evaluates if the right methodologies are followed, and then only the certificate is allowed. So that way organizations make sure that this Six Sigma or Lean methodologies are ingrained into the ways of working of every individual in the supply chain organization. Coming to the next function, it is warehousing. So warehousing deals with inventory management, tracking stock levels, and ensuring optimal storage. Space optimization, like efficient layout and minimizing handling times. So I believe day before yesterday or yesterday there was a session talking about automation, automatic robots or automatic cars, I believe. So I visited an Amazon facility in US, and there in the warehouse, no person goes inside. Everything is done by robots, and the picking and packing is done manually by once the robot goes in and brings the material, then the person picks that material and puts into the box. So imagine a Amazon order where you can order anything, right from a hard disk to a phone to some cosmetic or anything, right? Grocery also, anything can be ordered in one order, and that is picked by the robot automatically. So the automated guided robots actually go to, so a pick list is given to the robot automatically through computer order. Robot goes through various racks, picks up the material, puts into a basket, and that basket is delivered to a packer. And that packer just picks up the material from that basket, puts into a box, and then seals the box, because there's one visual inspection required before we send anything out. And then there is a label put, and the box is pushed onto a conveyor, and the conveyor will automatically move and put that box into a truck waiting. So there are like 100 docking stations where 100 trucks are standing, and then based on the area where it needs to go, or if it is a central warehouse, maybe the state where it needs to go. If it is a city warehouse, then maybe the area within the city where it needs to go. For that area, the trucks are standing, and then within 1 hour in the morning, all the orders get picked, packed, and then also stored automatically into the truck, and the truck leaves. So that kind of automation is already existing in companies like Amazon, and all those automation is not possible without data and advanced analytics. Space optimization, we would have already heard about the carousel systems, where there is a vertical stacking and robotic picking. So no one goes and stores anything by hands nowadays, especially small items. We just put it into a tray and the robot will pick, like a car, vertical car park, right? We just park our car at the ground level, and then the car will be automatically taken up to the fifth floor or seventh floor for parking, and retrieval is also automatic. So that same concept, carousel systems are available in warehouses. All this requires data and programming in the background. Okay, it's not manual. Automation using robotics and WMS, like warehouse management systems, for efficiency. Even line side feed is nowadays through a AGV. So if there's an assembly line where one by one material has to be given to a person who is doing assembly in a sequence, the AGV will move along with the material, and if there's a shortage, it will go and bring the material, and then the operator will just assemble. So all that is already there in the industry, getting used in most of the industries nowadays. Order management part, like order processing, capturing, validating, and fulfilling customer orders, is part of supply chain. Sales is not part of supply chain, but order management is. Sometimes there is a confusion of why order management here. But once order is confirmed from the customer, it is handed over to supply chain for fulfillment. So from that perspective, order management. So capturing, validating, and fulfilling the customer orders is part of order processing. Planning the demand, like forecasting customer demand to align production and inventory. Now this is forecasting and order processing. These are like complementary to each other. In order to make sure that the plant has minimum design standard material available to function, even without a firm order in place, demands are created, and those demands are then converted into firm orders as we get more and more clarity during the working, as months pass, as weeks pass by. But the material is available. We can't wait for the supplier order to customer order to procure material. And then handling inquiries, returns, delivery updates is also part of order management. Any questions so far on what are the supply chain sub-functions? Okay, I wanted to establish this common ground of what is supply chain by introducing these two slides. Now let's talk about what are the day-to-day decisions made in supply chain functions. So we'll go through the same functions and understand what decisions are taken day-to-day basis. So in terms of logistics, we need to select a cost-effective carrier, right? Which truck to, which carrier to pick, which can be cost-effective for moving our goods. Optimizing the transportation routes is another decision that logistics team has to do every day. Scheduling the deliveries, combining the deliveries for one particular area as far as possible, making sure that load is consolidated, like managing the load consolidation, because generally we pay per truck, right? Full truck load. Although we don't have full truck load, we generally pay by full truck load. If it is per parcel basis, it is expensive. So there's an effort made to load the truck fully, and for that load consolidation is generally done, and therefore sometimes we see Amazon orders are delivered after 2 days, although the supplier is in the city, right? It is generally consolidating the load. And handling returns and reverse logistics is also something, as we talked about at length, is a decision which need to be done on a day-to-day basis in logistics function. Coming to sourcing, choosing right suppliers, evaluating the supplier performance. How do we evaluate supplier performance, right? That's the question. And then there needs to be some metrics on supplier performance in terms of number of quality failures, the errors in terms of agreed rate versus quoted rate on the purchase order versus invoice, contract compliance. Then there will be a quality check. There will be a check in terms of practices followed at the supplier end. So there will be a supplier performance evaluation done, and then a decision has to be made on supplier. This performance evaluation is fed to the negotiation partners to see if there can be a better negotiation done with the supplier in terms of rate or in terms of performance, or evaluate alternative suppliers. Negotiating pricing terms is definitely a decision. Assessing geopolitical risk and planning alternative suppliers. These are day-to-day decisions every day in sourcing function. In procurement, approving purchase orders, determining order quantities, monitoring spend, ensuring compliance, and selecting payment terms. These are the decisions generally done in the procurement function on a day-to-day basis. Coming to quality management, obviously approving and rejecting raw materials, deciding corrective actions, right? We talked about CAPA, corrective and preventive actions. Scheduling audits, again, to the supplier from a quality perspective. Implementing the improvements found out through continuous improvement initiatives. And managing the compliance records for suppliers is part of the quality management process. In warehousing, the decisions are like allocating storage space, which space to allocate to which material, right? And then there are decision factors like, okay, is it fast moving material or slow moving material? What is the weight of this material? Then is it a safe material to store in that space, or it's a chemical or corrosive material, or something very odd shaped material, right? So all those factors come in when deciding on storage space allocation in warehouse. Deciding on stock replenishment in terms of when to replenish. And for there, we do have established MOQ methodologies, minimum order quantity, reorder point, based on the order cost and also the cost of the material itself and the demand. So this is a warehousing decision. Prioritizing order picking, like which order to pick first. Managing workflows allocation, especially in a warehouse, the workforce is a major decision. Holidays need to be managed. The work is manual there, so a lot of times there are challenges on the ground in getting the workforce to work in a warehouse. So how do we manage that? Night shift is a challenge. Coming early to work is a challenge, and generally shipment should move out early in the morning. So how do we manage that? And we say that order placed till 11 p.m. in the night is delivered in the morning. How do we manage this, right? So there are a lot of variables which come under warehousing decisions. And choosing automation versus manual. Sometimes automation requires a lot of programming, lot of data in advance, and then only the automation is possible, versus manual, I can just give a list and go pick and ship quickly. So depending on the situation, these decisions have to be made. As far as possible, automation should be chosen, but for that your system should be very robust, and there should be high volume. If there's a low volume, then automation becomes an overhead and expensive thing. Rather, it's easy to go and manually pick. Order management, validate customer orders. Sometimes what happens is the sales team will have some quotations made which are not compatible, right? The product cannot be made with those two options together. So we have to validate whether it is possible or not. And then if it is not, then work with the sales team to get it corrected. Set fulfillment timelines for the orders, handle inquiries, adjust demand forecast, and manage returns and exchanges. These are all decisions, day-to-day decisions in supply chain. Any questions so far? Okay. Now let's go to the second part of our topic, which is data. right? We talked about supply chain, we defined supply chain so far. We also defined what are the various decisions made in supply chain sub-functions. The topic is data-driven decision in supply chain management. So we are now moving to the data part. Now, data-driven decision making uh, is a process of making business decisions based on data analysis and interpretation, rather than intuition, guesswork, or experience alone. It is very important that any decision made can be justified using data. If someone asks, why did you do this? You should have a data in hand that because of this data, I made this decision. It cannot be, I felt that it will happen like this. So that guesswork and intuition experience doesn't work in a professional setup. And for that, we need to have a data available and data driven decision making in place. This is in place in most of the companies, but uh, just to eliminate that possibility of intuition, guesswork, and experience alone, I'm not saying that experience is not required. Most of the times, data plus experience is required to make a right decision. This data-driven decision making involves collecting relevant data, applying analytical techniques, and using insights derived from that data to guide strategic and operational choices. This is a very important statement that we have to collect relevant data, apply analytical techniques. We'll talk about those shortly. And then using the insights derived from that data to guide strategic and operational choices. Operational choices are like immediate. You have to do day-to-day decisions, take day-to-day decisions, and strategic are long-term, which may appear uh, less efficient in a short term, but in long term, those give better outcome. So developing a supplier and giving someone a chance to develop, although currently the quality is not good, but you know that that supplier is in strategic location. There is a lot of supply, tier two supply available, and if you invest into that particular supply base, eventually it will become an optimal source from logistics and cost perspective. Hence, you invest into that supplier by giving some orders, right? And then investing your time, you're sending your engineers there. Those are strategic decisions. Whereas you just take completely quality meeting material from some supplier, that is an operational choice, right? You don't, there's no strategy there. You are just getting material to run day-to-day business. So data-driven decision making is very important, and without that, no professional company can work. It should be evidence-based. Decisions are grounded in factual data rather than assumptions. So any decision that is made, you should be able to show why that decision was made. There has to be an analytical approach, like uses statistical models, machine learning, visualization. Not every time it is required, but you should have, for a complex decision, you should have the analytical approach to take decisions. And CI is part of everyday life in a company. So data is monitored and updated to refine decisions over time. The steps in making a data-driven decision, those are like we have to first of all collect the data, gather accurate and relevant data from internal and external sources. Data collection is a very important step in any decision making. Many times we have observed that lack of accurate data from a source because of accessibility issue. People create their own data or just put something in Excel and show. And this is a severe problem in companies. And with the advent of Power BI, what we have seen frequently happening is people create data in Excel and attach that to Power BI and show in Power BI. And then Power BI looks polished and looks trustworthy. And if decisions are made on top of that kind of a visual, then there are 100% chances of a compliance issue or a shortage or an excess somewhere downstream. So it is like uh, postponing the death. So those kind of things happen, and therefore it is very important to ensure that data is accurate and relevant from the internal and external sources. If the source is broken, or if some data is ingested in between by bypassing the complete pipeline, there will be problems and it will be termed as malpractice. Data cleaning and preparation is important, like ensuring data quality and consistency. So we'll talk about data quality shortly, but it is important to have the cleaned and prepared data for making decisions. On top of clean data which has come from the right source, we can apply analysis like descriptive, diagnostic, predictive, prescriptive analytics. Descriptive analytics, as the name suggests, describes the data, right? There are 100 purchase orders, or there are quality issues with this supplier. This is just a description. There is, it is like awareness, analytics for awareness. So there are a lot of dashboards in organizations which fall under descriptive analytics, where you see status. What is the status, right? And based on that status, decision need to be made. Then the next type of analytics is diagnostic analysis. So diagnostic analysis is going a little bit further than descriptive analytics to find out why, right? So descriptive can be termed as what is happening. Diagnostic is why it is happening. So there will be some root cause for, like, there are 100 purchase orders. Why there are 100 purchase orders, right? Because the demand has increased, or because there were quality issues, because manufacturing had some stoppages or machine stoppages. Therefore, there are more purchase orders in the pipeline, whatever, right? So there has to be some diagnostic made on top of the descriptive analytics, so that you know why a situation is there. And there are analytics methods to come up with diagnostic. Then the next is predictive analytics. Predictive analytics, as the name suggests, predicts the future, right? So time series analysis or machine learning analysis or even linear programming, all these are nothing but predicting the future. So we try to establish a causal relationship between a variable and a dependent and independent variable, and try to fit a curve or a line or something, so that next if you see one point on that curve, you can predict what will be the value of another point, x and y, in a simplistic terms. So predictive analytics is definitely something that is heavily getting used in industry. And then prescriptive analytics is, there is a prescription on what is to be done. Okay, it is the last level of analytics. And nowadays there's a perceptive also. I'll talk about that. But generally we talk about descriptive, diagnostic, predictive, and prescriptive. Prescriptive is the algorithm will prescribe what is to be done or what action needs to be done based on uh, some parameter. For example, let's say there are 100 sales orders to be fulfilled, and you can only, with the material that you have, you can only make say 50. Now which 50 out of those 100 need to be built? That is the question. How do we answer that question? For that, we can run some algorithms which can prescribe to us that, okay, build these 50 orders, and those may be optimized for revenue, or optimized for cost, or optimized for a particular set of customers. Like, say, government orders I need to fulfill first, or I need to optimize for consuming inventory which is excess now, and my quarterly results are upcoming. So I want to reduce my consume the inventory so that the results are good, right? So there can be so many KPIs which need to be met, and for that we can ask the algorithm to give us a prescription on what should be done, and that is all possible using this prescriptive analytics. Decision execution is the next step, where implement the actions based on the insights received by doing the analysis. And then monitoring and feedback is the last step in data-driven decision making, like tracking the outcomes and adjust strategies. So let's say we take one decision based on whatever algorithm was there, and that decision failed. Then you have to actually do a introspection, like what exactly happened. I took a decision based on this algorithm, but it did not work. Why? Maybe the algorithm didn't know one parameter which actually affected that decision. So next time I want to see if I can update the algorithm to include that parameter also. So these kind of decisions need to be made based on monitoring and feedback mechanism. Any questions so far on data-driven decision steps? Okay. The benefits are obviously improving the accuracy and reduce risk in terms of decisions. Data-driven decision making enables proactive rather than reactive decisions. So we don't react. Okay, there's a shortage now. What to do? There is a excess now. What to do? Instead of that, you proactively know that before I place this order, whether this will result into excess material or any delay in this order is actually going into a shortage situation. I should know that proactively and take a decision rather than just blindly believe on MRP output, place the orders, and then sit on a pile of shortages and excesses and not to know what to do, right? So therefore, data-driven decision making is very important in a day-to-day life of a supply chain professional, and enhances efficiency and competitiveness. Obviously, if you do the decisions like this. Uh, let's talk more about the data health now. Data health is basically a responsibility of business function. Okay, no one can come and increase the health of data other than the function itself. So when I say business is responsible for data health, we are talking about, in this context, supply chain. So the people in supply chain management function are responsible for ensuring the data is healthy. Now, what are the various parameters which are important to measure the data health? The first and foremost parameter is accuracy. The data should be accurate. The data should correctly represent the real world values or events. For example, customer address should match the actual location. Or let's say there are 5 components on the rack in the warehouse. In the system also, it should show 5 quantity. It should not show 6 or 7. Otherwise, what will happen is the MRP will take 7 as stock, plan according to 7, but actually only have 5. So any discrepancy between real world and the data is going to give rise to a wrong decision and resulting into last minute problems where for a wrong customer address you have to again take back the material, again send it. There's a cost, customer will not pay for that. Wrong inventory records, you assume that there are 7 but actually 5, so the 6th and 7th machine which you are going to build will have shortages. Although a planner will say there is material, the person in store will say no, there is no material, and then it will happen in the end when actually the machine has to be built, and then you have to run around and maybe expedite shipping, bring it by air, try to find out alternative part, work with engineering, go for a part change authorization, lot of stress, and then there is a customer approval that needs to be sought if you are changing the parts, and then it affects your company image and the future orders also. It's so important to have correct and accurate data, otherwise there are so many implications. Data should be complete. All required data fields are populated, like no missing values in mandatory columns. So there are 5 columns which are mandatory. If you don't have a value in 1 or 2 of the columns, then the programs will not run, or you will not, let's say the pin code is missing, right, or the phone number is missing, or some material classification is missing, then the MOQ is missing, let's say, then the algorithms which run will fail, and therefore completeness of data is very important, and no one else can come and do this, right? If you are in planning, then you are responsible for going through all the materials and making sure that the values are present for all the mandatory required fields, and those are correct, not just there but correct. The third part of data health is consistency. So data should be uniform across systems and formats. Some same customer name across CRM and billing system. It's a classic problem where SAP system will have some customer name defined, but Salesforce will have another customer name defined. Or supplier side also the same thing. Supplier name is, let's say, Tata Consultancy Services, TCS, TCS Limited, Tata Consultancy Services Limited, and so many variations. But it is one and the same supplier. Or the supplier locations like TCS Mumbai, TCS Thane, TCS Pune, means there can be so many variations. And then if there is a something wrong, then again, the supplier side problems, even customer side problems. Names, for example, billing information should be correct. Data should be valid. Data should conform to defined rules, formats, and standards. Typically, we see date format uh, goofed up, right? DDMMYY versus YYMMDD, or four letters in year, two letters in year, month spelled in 2 digits versus 3 letters. This results into a lot of programmatic errors, and lot of manual intervention has to be done. Therefore, data should conform to the defined rules, formats, and standards. Whenever there are multiple systems into play, like say there's a SAP system, there's a Salesforce system, there is some uh, engineering system, there's some quality system, and all those are interacting with each other, coming from different vendors, some in-house developed. Then these kind of problems arise, and then there's a lot of time spent in just combining data together manually using Excel and macros and all, which is actually killing the real value added time of a supply chain professional. It is very important to have valid data in terms of data health, and the responsibility again lies with the business. Data should be unique. We should not have duplicate records. Like I said, Tata Consultancy versus TCS. You should not have two rows, right? It should be only one row. So one unique customer ID per person is important. Similarly, for part number, I have seen many companies, uh, including the one where I work now or the earlier, same part is defined multiple times in the system. So part number 1, 2, 3, 4 is the same part versus part number 5, 6, 7, 8, same physical part defined as two parts. Now, as soon as you have this duplicate definition of part numbers or material numbers in the system, it's a huge problem, because I may have a stock of the same physical stock of 1, 2, 3, 400 quantity, and I require 10 quantity for my meeting my customer demand. But in the bill of material, I have 5, 6, 7, 8 defined. So what system will do is it will look for a stock for 5, 6, 7, 8. And obviously the stock doesn't exist, or the inventory doesn't exist for that particular matter, 5, 6, 7, 8. It will create a purchase order, and I will apply a minimum order quantity of 100 to that, because it is optimal, economical to buy in bulk. I'll buy 100, 5, 6, 7, 8. I already had 100, 1, 2, 3, 4. So I have 200 now physical. But what I need is 10, which I could have just consumed 1, 2, 3, 4. So, and this is a real problem. Okay. And why this happens? Because at the time of engineering is not in sync with the inventory team. Or engineering is a research organization where they create new components, whereas the day-to-day manufacturing uses whatever is in production. So new parts get introduced. No one checks whether it is already existing or not. They're just in a rush of completing the engineering project, new product design project, new part numbers get defined, and those get ordered. And there is an excess and obsolete problem, non-moving parts, lot of inventory lying around, which can be consumed if you have the correct data in place. So no duplicate record exists is a very, very important aspect in data-driven decision making and data health. And business again is responsible for data health. Last part of data health is timeliness. Data should be up to date and available when needed. So I don't know how many of you are in stock market, but imagine a share price is not updated. You see a one or early price, and then you try to buy it, and actually the price has moved, then it's a wrong decision, isn't it? Similarly, let's say there is some price information, supplier has increased the price, but it is not reflecting in our system, and we still place an order. And then the supplier will say, as per this contract, new contract, I am going to bill you this much. Then it's a liability to the organization to pay to the supplier with the increased price, whereas your order is on the lower price based on the old data. The store has issued material already but not updated the stock in system, and at that time MRP runs. So MRP will consider that already the stock exists, but actually physically the material has gone from that location. And then again, wrong planning. Shortages are upcoming next day or next week. So timeliness of data is very important. So our data accuracy, completeness, consistency, validity, uniqueness, timeliness, these are all data health aspects, which is the responsibility of a business function to ensure that data is healthy. And as the old saying, right, garbage in, garbage out. Any data-driven decision, if you feed garbage to it, the output will be garbage only. So the most important aspect of a supply chain function is to maintain data health for making the decisions that we just looked at in the earlier slides. Any questions so far? Okay. Going to the next slide, which talks about various types of algorithms. As you are going through this week of machine learning and AI week, right? I'm sure by now all of you must be well aware of these different types of algorithms at a high level, at least. Right? So still, I will just tell you what are the various. It is a spread of algorithms which are used in the industry for different types of data. Right, so let's start with supervised learning, a simple algorithm, type of machine learning algorithm where we train it on the labeled data, right? So we know X and Y, an equation is known, right? So based on the data, we try to fit a curve or a line on a data in simple terms, and then the new data we see where it falls on the curve, and the corresponding output variable is predicted. That is supervised learning. So you know that the causal relationship already exists. You feed the past data. Based on that past data, depending on the distance from that curve, the error is calculated, and we say that, okay, with this 95% accuracy, I can say that the output, if this is the case, the output will be this with 95% accuracy, right? That's what we say when we talk about supervised learning. This is a very well-known technique. We use supervised learning in many places. Time series is classic supervised learning, weather models, supervised learning. So there are so many applications of supervised learning which we implement within corporate world as well as public world as well, where you know the input output pairs and try to predict. In astrology also talks about the same thing, right? If the planet is in this house, then the person behaves like that. It's nothing but supervised learning, right? Um, Unsupervised learning is basically trying to discover patterns in the data, right? You don't know, you just have data. So you try to group data towards some clusters, right? Or you try to segment people by their characteristics, right? Or some uh, you classify heavy parts, light parts. You classify customers who like a particular celebrity. You classify uh, customers by their demographic, right? So there is unsupervised learning. You just throw data and try to group them in various clusters, right? And then assume that those clusters have similar uh, similar behaviors or similar characteristics. So unsupervised learning is like algorithms work with unlabeled data to find hidden patterns or groupings. There are no predefined outputs. Example, customer segmentation using purchase behavior, right? So there's a classic, I'm sure most of you already know this. There's a case study taught in MBA colleges about when uh, when diapers are sold, beer cans are also sold. And the reason being, generally the husband goes to buy diapers in a supermarket, and then the this is a Walmart case study, right? So in Walmart, they tried to look at the bills, right, and what goes together, and they found out that most of the bills, the people go and buy diapers, and in that same bill there is a beer bottle also. So to encourage this behavior, Walmart keeps diapers and beer bottles in the site, near site, so that husband goes, picks a diaper box and then picks a beer bottle and goes, and they amplified this behavior, looking at the patterns in the bills, right? So this is just a funny example, but there are a lot of these kind of algorithms. Even you go to a retail shop like DMart or anywhere, right? So there are some lead items like very cheap, 50% or 70% discount. So you go and try to buy that, but actually you buy so many other things, right? So what should attract a customer? For a day-to-day item which has to be bought, it is given at discount, and then the person is like attracted to the store, and then lot of unnecessary items are bought by the customers, right? lot so you can segment the customers based on purchasing behavior using unsupervised learning. uh, Semi-supervised learning, as the name suggests, is a mix of both, right? Use a mix of labeled and unlabeled data. Helpful when labeling all data is expensive or time consuming. So you have a lot of data, but you don't want to run the supervised learning algorithm for the entire data. So you do some supervised, some unsupervised mix, right? Classifying web pages only when only some are labeled, right? So this is one example of semi-supervised data. Deep learning is the next level of algorithm. It's extensively used nowadays. For example, I did one project as part of my MS program where I I worked for a company called Assurant. Assurant is a company which works in insurance space. It's a US company, and they process car accident claims which come to the dealers. So their problem was, how do we know whether the claim is legitimate or not? Because it's a company sitting in a remote location, right? They don't have presence at the dealer. So the problem they had was they used to get photographs of a damaged car, and then the challenge was whether it is a real photo or it is a fake photo. So we developed an algorithm, a deep learning algorithm for that company, which will first of all, from the photo, extract the number plate, then extract the metadata of that photo. So let's say the claim was made in December, 15th of December. So when a photograph is clicked, generally there is a metadata getting stored for the photograph. What do I mean by metadata is, you see, right click on a file, right? You see uh, the the parameters of the file, like file name, then file size, right? The date taken, date modified, those kind of attributes are none other than the metadata. That's what we call metadata. So for an image, there is a metadata. In that we have when the image was created, which can be extracted using a program which is available with image, that the metadata comes. So we wrote an algorithm which extracts the metadata to find out when was the photo taken. And then we used to compare that with the date of claim. And in that claim, there was a date when the accident took place, right? So we used to see if the image was before the accident or after the accident or on the day of accident. And then we used to flag whether this is possibly a fraud or not. And we surprisingly we could find a lot of such cases where the images were taken earlier to the claim, the date of accident itself. And this happens many times. Then there are like there were some other peers of mine who worked on a similar algorithm for Amazon, where buyers, when they buy something, they claim that the product received was damaged, and they take a photo and upload. So generally Amazon will say that, okay, so upload the photo of the damaged product. Now how do we know whether this particular photo is the of actual product which is damaged or some photo from internet? Because on internet you will see damaged product photos. So there are many people who do this, that they take a damaged product photo from internet and upload as if it is there. So that kind of a algorithm is developed to flag those products. So search the internet, try to find out for product photos, because generally the person will search the internet, right? So do that search, find photos, and try to match that photo with the photo in the image search. And if it is found, then flag that particular claim that it is a fraud claim. The image analytics in terms of invoices which are received, there's a lot of work to type those invoices into system, because I'll get a physical invoice, a PDF invoice, and someone has to type the information into system. So I have developed in my company, and it's not nothing new. Many solutions are there. So we can do optical character recognition using deep learning, right? So characters can be recognized and then transferred into a system. So a lot of application of deep learning is already in place. In COVID, we had developed one algorithm in COVID days. So if someone comes into the office without wearing a mask, we could detect. There was a web camera. So if you enter the office, if there's no mask, it will like buzz a buzzer that you are not wearing a mask, and the person used to be sent back. So that kind of implementation, again, it is an image recognition or video recognition algorithm. And these algorithms, the good thing about all this is we don't need to do fundamental research of writing the algorithm. If you know Python, if you know which packages to use, you can just load the packages and start using it. So it's easy to deploy. Obviously difficult to develop, but easy to deploy. That's what I'm saying. But in industry, deployment is important than development. Maybe in the academics field, the algorithm development is very important. But in industry, how do we use whatever is there to make better, faster decisions is seen as more important than doing fundamental research most of the times, unless it is a research company. Now, the next one uh, is reinforcement learning. So reinforcement learning, as the name suggests, is it reinforces the decisions. So for example, there is a robot and there are obstacles, right? And I want this robot to go from point A to point B, and there are not many obstacles in between, but it should go on its own. That's the uh, that's the task. I think yesterday evening there was some expert from, I think, Mercedes, who was talking about the car trying to understand the objects right on the road, and self-driving cars and autonomous cars. Same thing here, right? So you have to feed this program with decisions and the outcome of the decision, right? So I can take one action, and the action can result into a favorable outcome or non-favorable outcome. So what this reinforcement learning algorithm does is it stores the decisions, that is actions, and the resultant of each action, and it creates a knowledge table. I'm talking in a very simplistic manner here, okay? The algorithms are complex, but just to explain in this broader session, reinforcement learning will have some actions, and what happens on that action is stored as a memory in a memory table. So next time, I will not take an action which is giving me unfavorable outcome. So let's say a robot goes straight, okay, and then hits one, takes one step. So let's say it takes one step at a time. So it sees a obstacle, a wall, and still takes one step in that direction. So it will get a response that it cannot go forward, right? It stops. That is an unfavorable response. So it stores that, okay, in this, at this position, if I take a step forward, it is a wrong decision. Then it will try to take a step towards the left, maybe, and it goes through. So it will store that I took a step left on this coordinate and it was successful. So by doing these experiments, the robot will eventually reach the destination. It will take maybe 20 minutes for the robot from go from point A to point B first time. But again, I pick that robot and put back onto the point A and say go. Now it has that memory that the 5 steps ahead there is a wall. There I had taken left. So it will not take a fifth, sixth step ahead. It will take 6 steps on the left because it has that memory. And then it will go maybe within a minute to from point A to point B. Again, in that process, if some obstacles are changed, then it will again learn. Right? So it will keep learning. So that is called, in simplistic terms, reinforcement learning algorithms. Right? So an agent learns by interacting with an environment and receiving feedback in the form of rewards and penalties. Just the way I explained to you, like a training a robot to walk or an AI to play chess. So there is a reward or there is a penalty for every action, and that gets stored into the program so that next time the cumulative score is calculated. What is the reward for taking the step versus what is the penalty for taking the step? If reward is higher than penalty, then the step is taken. If penalty is higher than reward, then that step is not taken, in simplistic terms. And these kind of reinforcement learning algorithms are in place. The self-driving cars are great example of reinforcement learning. Or chess, we play chess with computer nowadays. Same example. Ensemble methods are combination of multiple methods, right? So you can combine supervised learning plus deep learning plus reinforcement learning. Combine multiple models to improve accuracy and robustness compared to a single model. Like a random forest model, combination of decision trees. So you run the algorithm again and again, like reinforcement learning kind of, where you try to exhaust all decisions. Don't just travel once to the decision tree. Travel multiple times taking various paths and then find out which path is giving you the best outcome. And then take that path going forward. That random, in simplistic term, what that is random forest. Right? You don't know at the start. You have to explore. The last is optimization algorithms, and I touched base on this a little bit earlier. Like mathematical models used to minimize or maximize objective function, often during model training, right? So maximize profit, minimize cost, maximize use of non-moving inventory, maximize government supplier full order fulfillment, optimizing, right? How do I need to tell the optimization function. Many of you would have used solver in Excel. It's a simple optimization where you say you maximize this particular cell by changing these cells, and you can put some constraints that the cells cannot be negative, the cell cannot be more than 100, whatever, right? So those constraints you put, and then run this algorithm like gradient descent we talked about in the earlier session also, I think, or non-gradient descent, right? So these are the ways in which we can optimize a particular decision for a particular optimization function. And all these algorithms are used in supply chain management for decision making. Any questions so far? Okay. Now let's go a little bit deeper into role of data in supply chain decisions. Uh, in logistics, the typical decisions, as we said, like selecting a cost-effective carrier, optimizing routes, or scheduling deliveries. There, the data required is like transportation cost data, real-time traffic and weather data, right? So, if there's a we use this, right? Google Maps we use. That's a logistics decision we do day-to-day basis. If there's a raid, we don't go there. We choose some other road. It's a decision based on data. And then what is the cost of going there? Whether we go by flight or we go by train or bus, decisions we make based on data, right? Delivery performance metrics, where Big Basket says it will deliver in 10 minutes, but it doesn't. Whereas Zepto and Blinkit does. So you'll probably go, if you need really something urgent, you may go for Zepto, right? Not for Big Basket. So fuel consumption trends, again, different modes. You can choose which one to go for based on the mode and the consumption. Sourcing, choosing suppliers, evaluating performance, negotiating pricing. These are the decisions. And data used for that decision is supplier scorecards, historical lead times, quality defects rates, market price benchmarks, risk index, and financial risk also. So if a particular supplier is not maintaining its finance in a right way, it has lot of debt, and then anytime the supplier can go bankrupt. If this information is available with us, we will not source from that supplier, right? Or we'll try to help that supplier if it is critical. So these decisions are made on these data points, and these data points are generally available from third party as well as your relationships. But without this data, we can't make these decisions. Procurement, like approving purchase orders, determining quantities, monitoring spend. We need demand forecast, inventory levels, spend analytics data is required, contract compliance data is required, and payment history, like how is the payment by that particular customer, right? So based on that, probably we can uh, book the orders or not book the orders, right? So all that I'm talking about is what data is used for these decision makings. Quality management, like approving, rejecting raw materials, scheduling audits, implementing improvement. These are the decisions in quality function. And the data used are like inspection reports, process control charts, supplier audit results, defect trend analytics, and Six Sigma KPIs. These are the data points based on which quality function makes decisions. Warehousing, like allocating storage space, deciding replenishment, prioritizing picking. This is what we talked about. And the data is like inventory turnover data, SKU velocity, space utilization metrics, order frequency patterns, warehouse management data. Without this data, and again, the data should be accurate, data should be of quality, all those factors, we can't make better decisions in supply chain management. Order management, like validate orders, set fulfillment timelines, adjusting forecast. So we need the customer order history. We need real-time inventory availability so that we can promise to the customer that what can be delivered. Forecast accuracy metrics. So without this forecast accuracy, accurate forecast, we risk shortages and excesses again. Service level agreements. Uh, there is a post-sales supply chain, right? Aftermarket supply chain. It's a big field, uh, which adds one more dimension to the supply chain. Generally, in a forward supply chain, we have a like quantity, a particular product, how much quantity is required, and then we say, I require this much quantity of this product on this date to be delivered to a factory. Right? That's it. But aftermarket brings one more variable to it. The location also changes. So the part number changes, the quantity changes, the date changes, the location also changes because the part has to be shipped to a customer location, and customer can be anywhere. It becomes a bigger problem when we are talking about B2C segment like laptops, right? If there is a service agreement for particular laptop, let's say a Dell laptop, to be serviced, right? If the motherboard fails or screen is blank, it has to be replaced. Now it will not be in a factory, right? It will be somewhere in Uttar Pradesh, Maharashtra, Kerala, anywhere the customer can be. And we have to make sure that, and if the service level agreement is within 24 hours we'll replace. Now how will you do that, right? You first of all don't know which monitor of which Dell monitor model will fail where, and then you have a service level agreement to replace that within 24 hours. So you can't keep stock of all those replacement monitors everywhere also, because the product itself is going through multiple cycles of uh, product versions, right? The same laptop is only valid for 1 year. Next year new version or new model is introduced, like iPhones, right? Every year new iPhone. So what what how do you service iPhone 10 now, or iPhone 12? You are on iPhone 17, and there is a Apple services there, right? We signed the Apple service agreement. So how will Apple plan for replacing the screen for iPhones 10 versus 17 has a different screen, different technology? How much to keep in stock? Where to keep it in stock? How do we ensure 24 hours service? So all that is part of service level agreement planning. So for that, we need the customer base data, customer location data. We need history, engineering history, and engineering design data of particular product. The product life cycle data has to be available. Like typically a motherboard works for 2 years and then fails. Let's say you know that, then probably you will find out already that where all this particular motherboard is available in the country, sold to the customers based on their IP address or last location, whatever it is, and which of those are completing 2 years, right? So there you probably want to stock your motherboard replacement stock. This decision cannot be made without data. Amazon promises next day order, nowadays same day order fulfillment. So they track what you put in your cart, right? Where you are. Generally, the things which we browse, we there is a procurement cycle, right? You are interested in something, you'll browse for that. You'll search for the product, you'll look and then leave it. Sometimes you add to cart and then leave it. You don't buy it. But after 5 days, you will come back and say, yes, I want to buy it. So within those 5 days, Amazon has already known that, okay, this person is most likely searching for this product, not on this Amazon, but somewhere else also. So the level of search is increasing, and therefore high probability buy. And in order to provide this person with this product immediately so that it doesn't go to Flipkart, Amazon will bring that product and keep in your city location, city warehouse location, and say that next time you go, you'll say that get it by today evening, right? If you are not a Prime member, it will charge you extra also for that, but you will be happy because you get it immediately. So all these algorithms based on data, there's nothing else, and these are all supply chain decisions. Any questions so far in role of data on supply chain decisions? Okay. Now let's talk about what are the various categories of analytics in supply chain or any other function. First one, we talked about descriptive, prescriptive, and other analytics, but generally these four analytics are used in day-to-day in supply chain. One is predictive analytics, another is optimization models, third is risk analytics, and fourth is automation and AI. This is where the most of the analytics play happens. Although we have four types of analytics, I have added risk analytics and automation and AI because of the prominence they have in day-to-day life of a supply chain professional. So let's talk about predictive analytics. Predictive analytics, as we said, it will use historical data, statistical algorithms, machine learning techniques to forecast future outcomes. It will predict something. In supply chain, it helps anticipate demand fluctuations, delivery delays, equipment failures, price changes, enabling proactive decision making. We'll talk about each type of this analytics for each function subsequently. Okay, but right now understand that predictive analytics is majoritarily used in supply chain. The next type of analytics is optimization models. Uh, Products like Kinaxis and now most products in SAP also, we have optimization inbuilt. So optimization models will apply mathematical techniques to find best possible solution under given constraint. So we talked about like optimize for revenue, optimize for cost, optimize for particular set of customers, optimize for say machine utilization, optimize. Let's say there is a bottleneck machine which has to be utilized 24 by 7. Otherwise, all other machines they have excess capacity. But unless you use this, you can't produce more. And if this machine stops, which is a bottleneck machine, then you are basically losing on the production. Then your optimization model for your plant or that particular department should be optimized for that machine usage, nothing else, right? And the second level of optimization may be a type of orders which will give you largest revenue or backlog orders. You fulfill the backlog orders first, then take the new orders. So these kind of uh, targets can be given to the optimization models, and this is day to day. We use this every day in supply chain function, like route optimization for logistics. Every day optimize the route based on traffic, based on number of parcels to be delivered, number of type of like day of the time of the day. Lot of parameters can be used to optimize the route. Replenishment planning, mix supplier mix optimization, these are all optimization decisions which are taken on a day-to-day basis.
पाच वाजेपर्यंत आहे, संपत आलंय त्याचं.
रिस्क रिस्क
डॉक्टर
analytics.
अभिषेक पत्नी. तुम्ही ओळखता का?
नाही.
त्यांचं
Shelar sir, is there a question?
हॅलो सर.
Okay. The next set of the analytics that is used is risk analytics. So risk analytics involves identifying and assessing, quantifying potential risk using data-driven models. So risk is very, very important aspect in supply chain, because every day there are challenges in terms of the current geopolitical risk. Everyone is aware. Supplier quality is a risk. Frauds are happening. SLA compliance risk is there. Like we promise something to the customer and we can't deliver, risk. And therefore, risk analytics is a very important aspect of analytics, which is getting used day-to-day basis. And then automation and AI is now bread and butter for supply chain, right? So most of the processes which were done manually, we try to automate those using RPA, robotic process automation, or IoT signals are getting used to predict failures in advance, so that proactively we go and replace the parts. AI to perform tasks with minimum human intervention. So everywhere we see use of LLMs nowadays, which can access knowledge and summarize knowledge. If you look at ChatGPT or Grok or the Google Gemini or any other AI products, the main differentiation it has from human beings is access to data and summarizing the data. It can access internet within a few seconds and summarize information as required. That is the main differentiation, right? And that has changed the game. So many analytics functions are using this, because gone are the days when you need to create Power BIs, static Power BIs, and then every day use the same Power BI. Nowadays, leaders want to ask questions and get answers, right? It can ask, okay, which supplier has a problem? I have an opportunity to sell more of this particular product. Tell me, can I build this or not? Right? These kind of questions are getting asked nowadays in companies, and those are getting answered by LLM by looking at the databases. That is the stage where companies are going, and traditional analytics is slowly moving away. I leading a analytics function can tell you that within 2 years there will be a drastic change in this descriptive analytics. No longer required. All will be question answers. Now I know we have to end at 5. So I had some use cases for each of the functions. I will skip this and I'll share this presentation. I would like to address one last uh, point. Okay, one or two last points quickly. So one is how organizations are adapting to new technologies. How are we adopting this technology? So we are shifting from descriptive to predictive and prescriptive analytics. So before dashboards and historical reports for visibility, nowadays AI-driven models predict demand, lead times, and risk. Next, prescriptive analytics recommending optimal actions like the model itself will suggest in order to maintain this much inventory you have to take these actions, right? And then human just says yes or no. That's it. Then integration of AI into core supply chain processes like demand forecasting. Nowadays machine learning models use point of sale data, weather and social trends. Inventory optimization, like AI calculates safety stock dynamically. Gone other days where someone goes and puts the safety stock manually. Based on the fluctuating demand and the supply side fluctuations, variations, AI will calculate the safety stock and then update it. And the MRP will run based on that safety stock. Supplier risk management is through AI, like AI monitors financial health, geopolitical risks, and flags the supplier, and also puts orders to other suppliers based on uh, risk of a current supplier. Logistics optimization, AI powered route planning, and ETA prediction. When you can have estimated time of arrival prediction based on the real time data uh, in terms of traffic or in terms of delays in the sea, whatever, right? It can optimize. And control towers are there, like AI enabled platforms provide real time alerts and automated responses also. So earlier control towers were like you see world map and then there are blips, right, where green and red. Nowadays it is like real time alerts and automated responses also are happening through AI. And simulate digital twins are in place, like simulate supply chain scenarios for proactive planning. So you simulate the real world into digital world and then plan, what if this, what if that. Those are all digital twin based solutions. Organizations have moved to cloud platforms already. Scalable data lakes like ML services, ML ops like machine learning operations. You must have heard about DevOps. ML ops is now normal. Like we develop new algorithms and deploy continuously. Automated model deployment and monitoring. And IoT plus AI like sensor data for predictive maintenance and shipment tracking. Uh, Coming to the organization changes, like how do you cope up with this, right? In a supply chain organization, there needs to be an analytics center of excellence created if it is already not. Embedding data science teams in supply chain functions is the need of an hour, and upskilling the workforce for AI literacy is must. Unless this is done, the organization is going to be left behind. Now, this is my last slide. Like how you organize for the future, right? So, like chief supply chain officer or chief digital officer should be the executive sponsor for analytics organization. There should be an analytics center of excellence in the organization. It's not IT, it's analytics center of excellence. It's different. It should have embedded analytics teams. Embedded analytics are the people who know the function process as well as they know the technology. So people who know both, those are called embedded analysts or business analysts. So by function, you should have people who know that function and technology together. They will capture the requirements, convert those into specifications, and get those developed through the technology and platform team. And there you should have analytic tools like Power BI, Power Apps, Microsoft Fabric, if it is a Microsoft house, right? And then there should be a data governance and quality team to enable data platforms and analytic tools. Change management and training is very important for a supply chain function, because a lot of new solutions get introduced, but though if those are not used, and if the people are not trained on the new solutions, all the effort goes in vain, right? So there has to be a dedicated team for change management and training. And KPIs and performance monitoring is absolutely important, because that drives the results of an organization. So I think in the world of AI, we change this now. Sky is the limit. We change it to imagination is the limit. The more you imagine, the more AI can do for you. And that is the new mantra. I would like to stop here. I think I'm almost on the time. So if there are any questions, please let me know. Otherwise, you can scan this QR code. It will open LinkedIn profile. You can connect with me if you have any further questions on this topic. Shelar sir, I'm done with my presentation now.
Yeah. Let me check the unmuting of this stuff. You can participant. You can unmute and ask the question.
Sir, good afternoon, sir. Rishikesh, sir. Hello?
Yes, sir. Good
Yes.
afternoon.
Hello?
Yes, yes. Can you hear me?
Sir, yeah, I can hear you. Sir, myself, Anil Kumar, Director Skill Development, Vignan University. Sir, I have posted a question, how RPA is useful for this optimizing the process of supply chain management, sir? Robotics process automation.
So, very good question. Robotic process automation, as the name suggests, is automating a process. And supply chain is nothing but all these functions are following processes, right? So, for example, we use our RPA for reading the invoices, PDF invoices automatically,
Okay.
and then extracting the information and uploading into a SAP system. That is an RPA. Or RPA is used for reading the customer field service reports, and then extracting the RCA from that text, and then creating the root cause for a particular failure. This is the draw RCA automation. There are a lot of use cases using RPA which can be implemented not just in supply chain, but anywhere there is a process which is repetitive. If someone does the same thing again and again, try to apply RPA there.
Actually, we started robotics and automation. I am the founding coordinator for that program, sir, at my university.
Okay.
And I'm very much happy as when I taken charge as director skill development. I led my first batch of robotics student to participate in the LAM research contest 2024.
Okay.
So, and one of my final recipient is currently working at LAM research at Bangalore also.
Very good, sir. Very good.
So
This year also it was a great challenge by the automation that you are talking about is actually robots.
Yeah.
Physical
Sir,
robots.
one thing as a skill development director, I always want to give best to my students. So initially we framed our syllabus based on UI path, sir, as a beginning. So we have other softwares like famous softwares like Automation Anywhere and Blue Prism.
Yes.
So whether UI path as a bachelor student, it is enough to gain the knowledge, or I have to go for either Automation Anywhere or Blue Prism, sir?
See, Automation Anywhere is the market leader as of now.
Okay.
But UI path now, see, the basic knowledge is important. How to build automation robots. That is important. The tool is okay, means we can train people to use different tool, but the basic concept should be clear, that the process should be repeatable. There should be a particular set of rules in place in order to automate. You can't automate a random process, right? Every time there is a change, you cannot automate that. So if that knowledge is there in the student with one tool, because we use automation anywhere, but some other company may use UiPath, right? But it's
Yeah.
okay. At a graduate level, we will look at knowledge than skill, right?
Okay.
Attitude is more important at a entry level. We look at people who are more like interested, go-getter, and therefore these the context that you talked about, right? We look at that only, that how students can apply their knowledge to solve these challenges, and
Okay.
only the students who can crack the highest level of challenge get offer from lab research.
Okay. Thank you very much, sir. That is a very nice presentation, sir. Actually, I made case studies on how to check the vendor quality and the risk that can be attained with the vendor using uncertainty principles. And I am handling data science subject also.
Great.
Whatever your session that has happened today, that is very enlightening me also.
Yes.
Thank you very much, sir.
Thank you, sir.
And
Thank
it
you.
is very nice to interact with you.
Yeah. Thank you, sir.
Thank you.
Okay. Any other question by anyone?
So
Okay. Shall I, sir?
we can stop here.
Yeah.
Let me conclude.